Hold on. I'm watching this here. Oh, we can see my screen. Yeah, you can see my screen, guys. This is WikiHow. So how to use satellites. So I'm not going to be using satellites, but I'm going to be making one satellite. So, in my radio framework, we have three channels: uh, receiver, sender, transmitter, receiver, and broadcaster and verifier. Basically the broadcaster channel is very important, but the goal is to have two radio systems act as a broadcaster. Basically have two radio systems. So for a mini satellite, so if this thing is strong enough, if there's a strong enough connection, it was satellite position. That's my hypothesis. Because if the radio signal is strong enough, yeah, very strong enough, you have a satellite, and you can have a satellite. So for example, I got my model here on the kind of system here, but I'm looking at the project. So that's my hypothesis. So it's a localized satellite. Basically, it was kind of the area is strong. You can have two radio dishes, or if you call them dishes, you can call them two radio channels, broadcaster and broadcaster, that are disjoint and hold the connection. They hold the connection to a space, local, for they hold the satellite connection with a lot. The satellites work by longitudinal waves, uh, but longitude. They work in latitudinal waves. Basically, they work on the Earth's equator. So I'm trying to use the equator to solve this problem. But if anybody has research, please let me know. What does this mean for quantum computers, Namely? So, Namely, imagine basically if you have one radio, not a dish, one radio command you choose your friend, and you take another radio, take two radios, put them apart. Let's say you have uh, the 16 feet apart, 16 foot apart, 16 foot, 16 foot. I'm 7 foot full, 16 foot full. There's an area. Let me just turn my camera here. Sorry, guys, I'm just like. There's an area. If you have a 60 foot, basically I'm 6 foot four, 6 foot four. So basically, if you have 8 foot distance, um, for one radio system, a radio system can only go 8 foot, 8 foot distance, and then another radio can go 8 foot distance. The center is 0 0, because they have a center of the shear center. But that shear center is an area of eight polar eight, what I call polar eight. So you're gonna have so if you have two relay systems and you have an area in the calculator now of eight foot of 8 foot of 8 foot, another range of 8 foot. Let me draw it now in the system. 8 foot, 8 foot, 8 foot, so that's 8 foot, 16 foot, 8 foot radio A, 8 foot radio B. You have a system of here. You have a I have a longitude. So you have a longitude, you have a latitude. Now that is basically the equator. You're gonna have the longitude. So you're gonna have the Tropic of Capricorn on top, Tropic of Capricorn, and Tropic of Capricorn, which is basically North America or Jamaica, those places. And you have the Tropic of Cancer, which is like Brazil, northeast, West Brazil, Brazil, really to the ice caps of the pole. So this is what I'm saying, you guys. So this is what I'm saying. So this should work out intended. So you're gonna have two type. We're gonna have two type. We're gonna have two type of transverse waves. You're gonna have longitudinal waves, latitudinal waves, which work on the equator. Again, which satellite uses. Again, the strongest, the most satellite goes to equator, because equator is basically where all the water things are. So the more you get a signal on the equator, so you can have longitudinal waves, and latitudinal, which looks like an X component of the metrical of X components of latitude goes across the equator, and longitude. Now, longitude is basically, I don't understand longitude, but they cross they go to the south, they go to the North Pole. So they're polar magnetic. So they go to the North Pole and South Pole. So they understand them wrong. So they're gonna go to North Pole. So longitude goes from north to south, which is basically this is North Pole here, the direction I'm facing here. Sun is in the east to west. So north east so Soros is the north. So it's the east. So Soros is the east here. Okay, so this is east here. I'm facing guys. So north. Soros is the east. That's the west side. This is the west side. You know, I'm sure now. North, east. Wait, this east. Yeah, this is east. This is west. Sorry, guys. This is west. This side is west. So I'm facing east, north. So this way the local propagates most, and there's a polar magnetism there. No, but there's an electromagnetic frequency, EM frequency. Probably can't separate them apparently, and a lot of what they know is wrong. But it's good to admit that to continue. They have an area they cannot basically they have an electromagnetic field, like a field that you cannot lose connection. You can have a stable, strong connection to the internet. So this is basically a radio internet, but it's gonna work on a strong waveform. So because there's a lot of broadcasting, you're gonna get a lot of results. So you're gonna have you're gonna have three radios in this model. But to have to change anything have two radios, to have a still S for sugar, T for tango, E for alpha, E for echo, F for lima. So that's the Sarah. Two S's for Sarah. That's still because you're gonna have two radios. So you're gonna have one broadcasting, uh, 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 and uh, and transmitting. You're gonna have one broadcasting and receiving. Very important. You have that order. You're gonna have one another radio channel. Basically, you're gonna have two radio channels. So in this two kind of space, you're gonna have 8 units apart, 8 feet apart, and in that 8 foot, you have 8 plus 8. 8 plus 8 is topology. You're gonna have 8 times 8 long 8 times 8 p. 8 plus 8 is 16. 16 times pi. 16 times pi. Okay, 16 squares, 16 times 16, 16 to the power of 2. 16 times 2, this is 32. 32 pi I. 32 times pi. 32 times pi is 300 and 100 and 100.53 degrees. Now, basically, this 153 degrees of the rotation, 105 degrees. So basically, this radio one can be so this is 105 degrees. You have minus 105 degrees, right? Uh, uh, model yeah, so yeah, you're gonna have that. So you're gonna have 105 degrees, 105 degrees, model 260, gonna be 205 degrees. You're gonna have to pull it inverse, you're gonna have, and then you have to, so yeah, so the optimal rotation is 105 degrees, 100, no, 100, the 53096 degrees, rotation. Basically, the optimal path to the equator, to the center of the equator, basically the center of 00. So basically, these radios are always proceeding towards that way, 100, but they're sending them opposite directions. Can I just calculate this? So I hope this is right, but I'm saying that, I'm claiming that, if the system, if any system is broadcasting, hypothetically, if two radios are broadcasting, you can have a connection to, you can make a strong connection at a central space, and that space is 100 degrees per 53. 53 minus and minus 100, so but just the facing that angle, they'll be facing center, they'll be facing like so they'll sit like this, and though that center area will never lose connection to a service like an internet. So doesn't matter whether it's a radio wave or radio wave transmitted data via polarizers. But I know people are gonna poke on my theory, but I love to understand but I don't understand what I'm doing here. But I'm just trying to make sure that the signal is connected. So you can have a satellite, you can have this is a localized satellite, satellite dish. It's a localized satellite dish. So you're gonna have doesn't matter the space you have. But you have like so you're gonna this is radio system, you're gonna have this one too. So you can have two radios there. So this represents two radios, so you have a radio 1 and radio 2 here, and they are there, and they are just sending signals to the center the center. But you're gonna have radio 3, which is basically controller, controllee, and then you're gonna have radio 3. Now, radio 2, you don't even need radio 3 with him. Radio 2 can be a guest or some kind of someone that can be someone trying to use the internet. It can be a user of the peer-to-peer network of the internet. But you see, there's 3 people, but that person is basically part of the network. So they keep broadcasting more waves. So basically, the area amplifies. So the area amplifies. That's the beauty of it. The area amplifies. So if one person comes to 8 foot into 8 foot radio and say, "Oh yeah, let me join the welcome. I'm on radio channel." The network, so it never breaks down. It never have to cut out anything because the radio system is at the center, and that center just keep broadcasting connections to the people. You get more people joining the network. So that's the beauty of it. Basically, satellite connection, but it's a localized satellite connection of a radio system. Thank you guys for watching this video. If you like it, share, subscribe, and there you go.